Hi John. So this is part two to the CA3 multiplayer screencast 2018 with Zillan, Patrick, and Tom. So yeah, so I'm just going. So what I talked about there was how we did it overall as a team, the DC, how the team did individually, what I did, and then I went into showed you the code that I wrote. Then I went into describing latency, jitter, reliability of the network, and I just got out of time there for describing the client, the server, and the project in general. So I taught myself there that that last section was just a little bit rushed. So and also I didn't get it finished. So I'm just going to go over this one more time from the beginning. So we have so in our solution, we have three projects. We have RoboCat, RoboCat Client, and RoboCat Server. So the reason that we have three of these is for organization, for one, and two, that we need two projects. We need to be able to run two separate things at the same time. So what we need to be able to do is we need to have one project which hosts a game, and then we need to have another project which can access the attributes of that game and then make a game on that PC and then interact with the other PC that is hosting the game, get values from it, and update the game based on those values. So that is the relationship between the client and the server. So when we are demoing or playing the game, what we do first is we open up the server and then we open up the client. We don't open up the client first because the client relies on the server to run, so, or to get data off it. So we can run the client, but nothing will happen, or we'll just see a blue screen. So what the server does when you run the server is it allows people who know your IP and know what port you're using to and who have your game to play your game together in a communal error. So that's when you saw multiple different submarines in our loading screen. What the client does when the client runs, so sorry, when the server runs, it will try to access the port. If the port is accessible, then it will start the server and then it will send out saying, yeah, we're ready to run this game. On the client side, what the client will try to do is it will try, first off, it will run, and then second off, it will try to find the server that is running based on the IP address and the port that you give it in the settings. And then if it can find that server, and if the server is already running, then it will connect itself to the server, and then the server will say, yep, okay, I recognize you, and give the player an ID, and then that's how the connection is set up. So in so that's the sense. And then in terms of RoboCat, that project there is just a project which holds the files which are not specific to either client or server, but are used by both. So it's sort of like an extra library that is used. So you wouldn't actually run RoboCat like that. You would just run a server and then you would run the client. So lastly, I'll just go over like a main overview of what the most important files are. So in server, obviously the most important file is the server. So this is what is used to set up the server, and then run it and start the game. Another important one would be the client proxy. So the server uses a client proxy. The client proxy is sort of like a visualization for the server of what a client looks like. So then it can sort of tell what needs to happen, and it can use the client proxy to sort of predict or sort of tell how the clients are getting on and that sort of stuff. For specific items in the game, we might have our own server or like file. This is just another file that has certain methods that are all related to a certain thing. So we just put it in another file. So it's just the same thing. So for this instance, we have a mouse server, but we could have a submarine server or like submarine color server. You could have like a pickup server. You could have anything you wanted really in this sense. And like for example here, like one of the methods for this is handle collision with cat. So if what you're saying here is if the mouse runs into a cat, then do something. In our game, we've changed this, and now it's if the mine makes contact with a submarine, then you're going to do something, and in this case, you're going to take 1 point of damage from that specific submarine, which is in cat here. Yeah, and then I think that's the server. So then network manager would be just yeah, the network manager manages the network connection. So it's what's used to output packets. So process packet and then send them out to the actual to that in bit stream to actually send them out. That's used for. So then in terms of client on the other hand has client CP.cpp, which is used to actually run the client, and then it has other things like input manager, and then it has a rendering. This is more to do with actually showing the game to the player and getting input from that more than actually anything else. So the server sets up the server and the client runs the game. So I think that's everything that I'm going through. So let's check the thing. So I went through overview of client, yes. Overview of server, yes. Structure serialization. Okay, yeah. So one last thing just before I go is just to explain serialization. So one of the benefits of that we used in this game or learn from you is that we are now able to manipulate data into the byte level, so that we can now send data a lot more efficiently over. So for example of this is if we are sending an int over and for like health, and we have int 32, so I think that goes up to 560, or it goes up to a huge amount of bits, and the actual health that we have, it only goes up to 100. When we're sending that data over, we'll only ever be using the amount of data. We'll never be sending over set player's health to 1,000 because the max is 100. So we don't actually need all those extra bits. So when we're sending those over, the extra bits will get dropped, and then the 3 bits or the 4 bits that are used to send over the 100 or the max level of 100 will be sent over. That'll be sent from the server to the client, and then on the client side, the client will take the packet and then see, oh, okay, this is a health, but it's only like half an int or like an int size, that there's some bits that are missing from this, but I can assume that these are the zeros because health is only going up to 100, and I have all the data that I need. Using this, we can also send multiple bits of data, multiple types of data at the same time in the same packet, which speeds up the process a lot more. And then we have game synchronization, game persistence. I've talked about the discussion about this, gameplay, in-class demo, structures. Okay, John. So that's the end of the screencast. Thanks very much for everything. I had trouble with this module, I'll say, just to put it lightly, but I still think it was good, and it was nice to be able to make an actual game that was like sort of something different, and I can go, and I think what I'm going to plan to do over the summer is probably get that book. I'd recommend to lead. I think Patrick already gave it to me, and then sort of work through your code maybe, because I actually want to play this game, make some games, and maybe get some of my friends to play them. So thanks very much, and have a good day, I suppose. See you later.